We were reading these 4-bit registers और counters के बारे में बात हुई थी, और ये registers with parallel load है. This is the register with parallel load, 4-bit register with parallel load. Anybody who can explain me that what is a register with a parallel load? Ji,
Yes,
what do
sir.
you remember from the last lecture? What is this?
ये पैरेलल वाला रजिस्टर वो था, रजिस्टर था 4 बिट।
Yes, yes. और ये
सर
load
इसमें वो पिछले वाले में
what does this load switch do?
सर वो मेमोरी जब हमें रिपीट करनी है तो हम लोड स्विच का इस्तेमाल करते हैं ताकि इकट्ठे जो है वो इकट्ठे लोड हो जाएं, और जब कभी इस तरह से सेट किया जाता है कि वो दोबारा मेमोरी जो होती है वो रिटेन भी कर सकता है अपनी।
Yes, yes, exactly, yes. अगर जैनब ने भी किसी हद तक सही जवाब दिया है in the chat box. If we have a 0 over here and we want this 0 to be retained, even if even if I0 is 1, and we do not want this I01 to be shifted to A0, so what we do is we put a 0 at the load over here, so we get a 1 over here. This 1 is shifted to this place, so whatever would be coming from A0 would be transferred to the output as well. So this A0 over here, this represents that if we have put load equal to 0, then the output of this AND gate is always going to be equal to A0, and the output of this AND gate is going to be equal to 0. Why is that so? Because after inverting this one input, a 0 would be acquired over here, a 0 would enter over here. Okay, so participants are still joining. Let me just add them. Okay, so a 0 would be added over here, and this would make sure that the output of this AND gate is 0. So the output of this OR gate would be equal to A0. That means the output, the previous output that was holding at the output of this D flip-flop, which was actually 0, and a 0 would be passed to A0. So the method that we have over here is that if load is equal to 0, the output of our system would retain itself, because the output would be transferred back to the input, and in the same way, and in this way, we'll have the output retained. So this configuration is really important. This configuration, you have to remember this configuration. This is important in means of retaining the outputs. This is not only for the case of this 4-bit register, but you might have different cases where I would want you to retain memory. I would want you to retain memory of a certain circuit, and I would say that design a circuit that retains memory. So you should remember that this portion of the circuit, if it would be applied to any of the latches, any of this portion, exactly this one, this portion of the circuit, if I apply this portion of the circuit and I might change any of the ICs over here instead of this positive triggered or whatever, this would make sure that the output would retain itself, because this is a method where output is being sent back to the input very carefully. If load is equal to 0, the output would be sent back to the input, and if load is equal to 1, the fresh input would be sent to the D input. So this is a really important circuit. So for all of you जो पूछ रहे थे कि सर problems किस तरह से आएंगे, क्या होगा, so the first design thing that I have told you over here is this circuit. That is basically a trick. That is basically how. Yes, Dishan, you want to say something? Okay, so if I ask you that we need to pass the output back to the input, or we want to have a feedback, or we want to remember, or we want to retain the output, then only this circuit would help you. So you should remember this. Any questions related to this? Any question?
No, sir.
Okay, okay. So we have a shift register over here. This is a 4-bit shift register. 4-bit shift, okay, Zishan, it's fine. 4-bit register is something that that has a serial input and a serial output that is evident in front of you over here. So what do we mean by serially transferring data? one of the data transfer was over here and this was being controlled over here. This is known as parallel transfer. Parallel transfer means at once in a single positive edge of the clock. If this is a positive edge of the clock, that is quite a bad clock, but still I would suppose that you guys would not take it seriously. After each positive edge of the clock, all of the 4 bits I0, I1, I2 and I3 are sent at once to the A0, A1, A2 and A3. Is that right? Do you guys agree? Because we have the same clock, so at each positive edge of the clock, I0, I1, I2 and I3 would be transferred to A0, A1, A2 and A3 at once. Is that right?
Yes, sir.
Yes, sir.
So if you have a look at this diagram over here, we have a serial input Si and a serial output. Do you think that if a data I0 was transferred over here, what would happen to that? So at each positive edge of the clock, if we have these positive edges of the clock, and I say that here we had I0, here I had I1, here I had I2, and here I had I3. So at the first positive edge, this one, what would happen? At the first positive edge, we would be having I3 over here. What would be present over here?
I2.
I2. What would be present over here?
I1.
I1,
I1. And over here?
I0.
I0. How did this happen? Because at each positive edge of the clock, our I0, I1, I2 and I3 that are present at the D inputs are going to be transferred at the outputs over here. This output, this output, this output and this output. So this means that I0, I1, I2 and I3, these 4 inputs are basically going to be transferred one by one to the serial output. We would have some catcher over here, some other flip-flop over here or some other device over here. But there is a difference that occurred between this circuit and this one. And what is that difference? That in this circuit, we have all the 4 outputs, all the 4 bits transferred at the same time. Is that right? All the 4
Yes, sir.
bits are transferred at output at the same time. Whereas in this case, the output is only having each bit one by one. So for the first positive edge, we'll have I3. For the second positive edge, we'll have I2. For the third positive edge, we'll have I1. And for the fourth positive edge, we'll have I0 over here. So in 4 clock cycles, we would be receiving the 4 bits. Whereas in 1 clock cycle, we would be receiving the 4 bits over here. Is this okay?
पर
Yes.
पर इसमें मेमोरी रिटेन नहीं हो सकती?
मेमोरी रिटेन करने का क्या मतलब है हुर?
कि सर मतलब जो एक की अगर I2 है उसको हम दोबारा रिपीट कर लें, जिस तरह हमने पिछले वाले में पढ़ा था कि हमने I1 दोबारा से ट्रांसफर कर दिया था जब क्लॉक वो थी.
Okay. I get that. So we have this in a flow. Okay. अगर मैंने 1, 0 1 1 transfer करना था. So 1 0 1 1 has to be transferred as a whole. Okay. Similarly, over here as well, if I had to transfer 1 0 1 1, then 1 0 1 1 had to be present at 1 0 1 1. Is that right? यहाँ तक बात clear है?
Yes, sir.
Okay. So once all of these 4 bits have been transferred, then I want to retain the memory. Then I say that this circuit helps me because I would make the load 0 and again a 1, a 0, a 1 and 1 would be retained over here. So this would help me to retain 1, 0, 1, 1 over here. Is this okay?
Yes, sir.
But what happens over here is that until and unless I have received a 1 over here, then a 0 over here, then a 1 over here, then a 1 again over here. Until and unless I have received all of the 4 bits, I do not want to repeat the cycle. So once the cycle is repeated, once the cycle is done, then I would transfer the 1 0 1 1 back to this place. How am I going to do this? This is going to be done through this procedure. I'll show you how to do this. But first of all, you need to understand that the first thing is to completely send the data at the output, at the serial output, and the complete data would be sent in 4 positive edges or 4 cycles of the clock. Is this right? Is this okay?
Yes, sir.
So for this circuit, we would be transferring the data back towards the input. That's quite a dirty slide now. Okay. So if you see, I send the data from serial output back to the serial input. What happens is that if I had 1, 0, 1, 1, then not only this 1 would be transferred at the output, but also at the input. So the next input over here would be 0, 1, 1, 1, and again a 0 over here. Is that right? So the next input over here would be 1, 1, 1, 0, 1. And similarly, the cycle would repeat. That would be 1, 1, 0, 1, 1. And for the last time, we would be having 1, 0, 1, and 1. So we would get back to the point where we had started. Is that right?
Yes, sir.
So is this okay?
Yes, sir. Sure. Thank you.
Okay. Okay. So this is how we have made a 4-bit shift register. And this is how we made sure, Zainab, what should I repeat? Getting back to the output. Okay, okay. So for all of you, is only her and Zainab listening, or the other are listening as well?
Yes, sir.
Sir, we are ready.
Okay, समझ आ रही है सबको?
Yes, sir.
So Hur had asked
Yes, sir.
that how to have the data holding technique that we used over here as well. So the first thing that we were differentiating between the two circuits is that this is a circuit where we are sending the data in parallel. This is known as parallel communication. This is not a bit-to-bit communication. Okay. So where we have this circuit, and in this circuit we have a shift register. In a shift register, you cannot send all the 4 bits in one shift of a clock, in one edge of a clock. In parallel register, in parallel circuits, you can send all the bits in just one edge of the clock. Is this okay? Now, in this parallel circuit, this circuitry was enough to hold the data. So this stores the data, sends back it to the input, and then the output repeats itself if this load switch over here is kept 0. But if you have a look at this circuit, we have data I0, I1, I2, I3, and I3 was here if the data was 1, 0, 1, 0. Okay, I'll just repeat this one with this circuit. So 1, 0, 1, 0 would be transferred to the output all at once. 1, 0, 1, 0 would appear 1, 0, 1, 0 over here in just a positive edge of the clock. But what happens in this circuit? In this circuit, we'll have to have a 0 over here, a 1 over here, a 0 over here, and a 1 over here. And they would be transferred to the output turn by turn. If we want to hold the data, we want to repeat 1, 0, 1, 0 again and again. We will take a wire from this side, place a switch, maybe you can have a AND gate, that if AND gate output is, this is the load input. If I say this is load, and after this AND gate, I push it back to this input. Now what would happen after the first positive edge of the clock? After the first positive edge of the clock, a 0 would appear over here, a 1 would appear over here, a 0 would appear over here, a 1 would appear over here. And since we have connected this output back to the input, and we would be having load is equal to 1, for example, a 0 would be transferred to this side. So for the next positive edge of the clock, a 1 would appear over here, a 0 would appear over here, a 1 would appear over here, a 0 would appear over here, and what would appear over here? At this side?
1.
Yes.
1.
Yes, exactly. And until we have 4 edges of the clock, that means that we would have 0, 1, 0, 1 over here. All the 4 bits were transferred. The next copy of this circuit, the next copy of this information would be ready in the diagram behind it. Is this okay?
सर
Yes.
सिर्फ जो हम I3 पे 0 भेजे अभी हमें क्लॉक का पॉजिटिव चाहिए होगा ना I3 पे जो 0 आ रहा है I2 पे क्योंकि इनपुट तो एक ही आ रहे थे
I don't get it. What did you say?
सर इस तरह I3 पे 0 है I2 पे 1 है I1 पे 0 आपने लिख दिया पहले ही तो इसके लिए भी हमें पॉजिटिव एच के थ्रू ही इनपुट करना पड़ेगा ना
Yes. All of these data, all of this circuit, they have reached over here through the positive edges of the clock, and for sure we'll have a reset button over here as well. Okay. In the practical circuits, a reset button is a must. A reset button is a really need of the hour for practical circuits. Okay.
ओके सर
Okay, so there's one thing that is really important, and I want all of you to be very attentive. I did not play with the clock. I could have retained the output by placing AND gates at the clock, by suppressing the clock, and by maintaining 1010 at the output. If I had placed an AND gate at the clock, I would say that I am retaining the output by just putting the clock off. Is that right? Is everybody attentive to this?
यस सर
I
Yes.
could have retained the output by pausing the clock for this shift register, but I didn't do that. I would never do that until and unless it's just inevitable. Why? Because playing with the clock, placing any gate at the clock would create delays in the circuit. I want each and every part of RAM to work in synchronization with each and every other part. I do not want a microsecond, a picosecond, a femtosecond delay. I do not want that this 4-bit shift register works 10 microseconds after the previous 4-bit register. If I have millions of 4-bit registers, I would just want each and every one of them to respond to me to the same time. By placing a AND gate over here, a switch over here, the clock would be delayed. The clock would be given a propagation delay, even if the gate is on or the gate is off. And I do not want that. Is this clear?
Yes, sir.
Is everybody clear on this? I want
Yes, sir.
everybody to be clear on this. Why do I do not want a
Yes, sir.
clock signal to be controlled? So I would be asking these questions in your exam, that why do we do not control the clock signal, and why do we have these circuitries attached to the D inputs? Okay. So this one in front of you is a serial transfer from register A to register B. Until over this, we have studied about a single register. Let's suppose this is called A. This is a 4-bit register. Now in this diagram, we are studying about a serial transfer from register A to register B. Let's suppose that this register A is 4-bit. And this register B is 4-bit as well. So this means that this register B and this register A has each of the internal circuitry as shown to you in this diagram. Is this okay? Is this okay?
Yes, sir.
Okay. So we have a 4-bit shift register A and a 4-bit shift register B. Now please be very attentive. This would be the last thing that we are studying in this lecture today. There is a serial output A, serial input A, serial output B, and serial input B. Data from this source register, this register, shift register A, is called the source register. Okay. And data in the source register needs to be retained. It needs to be retained. That means we do not want to lose data in the register A. We are not worried about the destination register B. It might be going to any place over here. This might go to any register B over C over here, D over here, wherever it goes. But we are careful about the source register. We want our data at the source register to remain the same. So let's suppose that we have 1, 0, 1, 1 in the shift register A. Is that right? We have 4 bits in the shift register A, which is the source register, and we want to transfer this data to shift register B, which is in front of you over here. Two things that you are able to see over here. One is this wire that is going from serial output A to serial input A. That means that is helping us to retain the data in shift register A by the question that Hur had asked over here, that how to retain this data. And I had told you with the example that this data is going back to the input. And so in this way, our data would be stored. The second thing that you have seen over here is this clock with a shift control gate. Okay, so this seems that we have created a problem for us over here, which is the propagation delay problem. But since this was inevitable over here, so we have placed it over here. इसके बगैर हमारा गुजारा नहीं था, so हमें ये करना पड़ा यहाँ पर. ये शिफ्ट कंट्रोल रजिस्टर बन रहा है, सीरियल ट्रांसफर होने लगी है यहाँ पर. So how is this going to take place? Just have a look. This clock is with a switch which is shift control switch. Until and unless I have shift control equal to 0 until this point, there would be no clock that would be passed to shift register A or shift register B, and the data that remains at the SOB, SIB, SOA, and SIA would remain the same. Then a 4-bit data comes out to the source, and I am allowed to pass that 4-bit data to shift register B. What I would do is I would turn the shift control on, as you can see in this area. The shift control has been turned on over here. By turning this shift control on, please be very attentive, from this area to this area. When did I turn it on? I turned it on at a negative edge of the clock, if you can see this. I turned it on at the negative edge of a clock. I waited for 4 positive edges, 1, 2, 3, 4, and I stopped it. I stopped the shift control at the next negative edge. That means I have 4 positive edges, 4 clocks over here. Can anyone tell me that why did I wait for 4 clocks?
क्योंकि 4 inputs है.
Yes, because we have 4 bits. 4 bits of data. 1, 0, 1, 1. We have 4 bits of data that needed to be transferred. Yes, Zainab, you're right. So this 4-bit of data would be transferred to the shift register B. How? First of all, this 1 would be transferred over here. Then 1 would be transferred over here as well. The second thing that would be transferred is a 1 again, and a 1 to the input of this SIE again. Then a 0 over here again. Then a 1 and a 1 over here again. Is the working of this serial transfer from register A to B clear? Any questions? You see, this is the shift register A. This is the shift register B. The initial value was 1011, and we say that the shift register B was standing at any random value. So at the first positive edge of the clock, this 1 transfers to this place and this place as well. The next thing that happens is this 0 goes over here. That means we have this 1 transferred over here and over here as well. Then this 0 is transferred over here and over here as well. Then this 1 is transferred over here and over here as well, which completes our sequence 1011 again, and 1011 has been completely transferred to the shift register B. Is this okay? Any questions?
No, sir.